Hi everyone. Am I audible, guys? Okay. So, hello everyone. Welcome to PCD of today's Codeforces Date 3 round, which was CF round 1013. Today, we'll discuss the problems A through F. But before we start, I would like to tell you about our all new CP31 sheet by TLE Eliminators. In case you didn't know, this CP31 sheet encapsulates 31 handpicked problems from each rating of from 800 up to 1900. So as you can see that my Wi-Fi is not working. My bad. Anyways, so I was saying that this sheet actually encapsulates all the problems, like 31 problems in each rating from 800 up to 1900, and they are picked in such a way as to teach you a new concept in every problem. Every problem. Added to this, every week, 7 to 8 solutions will be posted on our YouTube channel, so you don't have to search for the right problems anymore. So the link to this sheet is in the description, and let's get started. So today we'll discuss A to F. So let's start with A. The problem says that the final of the first Olympiad by IT campus Newark is scheduled for 1st March 2025. A nameless intern was tasked with forming the date of the Olympiad using digits 01032025. To accomplish this, the intern took a large bag of digits and began drawing them one by one. In total, he drew n digits. The digit AI was drawn in the ith turn. We suspect that the intern did extra work. Determine at which step the intern could have first assembled the digits to form the date of the Olympiad, or report that it is impossible to form this date from the drawn digits. Note that leading zeros must be displayed. Okay, so the problem is that basically you have to make this date. Okay, 01032025, right? 01032025. Okay, and for that you are, or the intern is picking numbers from a bag. So he has a bag, and from that he is picking up some numbers, and it has been given that what is the sequence of numbers that he picked. So in the first test case, he picked 2, then he picked 0, then he picked 1, then he picked 2, and so on. And you have to report that after how many picks was he able to form this date, right? So in this case, like in the first test case, basically if you have the first 9 digits, then you will be able to form 01032025, because you have this 0 1, then you have a 0 3, then you have a 2, then you have a 0, you have one more 2, and you have a 5 also. So basically you have all those sufficient unnecessary digits, and you can make that date. And this is the first time that you can make it. Like, you cannot make it using the first 8 digits because there are only 2 zeros. You need 3 zeros for that. Okay, so that's the problem. It is asking us that what is the first time at which we are able to like make the date, right? So this is a pretty easy problem. That basically, what is the condition for making a date? That basically your number of times that you have picked 0 should be at least 3, right? So the frequency of 0 up till now that we have picked should be greater than equal to 3, because this and this 0 we need. Then similarly, frequency of 2 should be at least 2, frequency of 5 should be at least 1, and also frequency of 3 should be at least 1, right? So if all four of these conditions are satisfied, then you can say that you will be able to form this date, right? um okay, I think this doesn't add up. 3 plus 2 is 5 plus 7. So but these are 8 dates. So what am I missing here? 3 zeros, 2 ones. Okay, yeah, okay, one also. So frequency of 1 should be greater than or equal to 1, right? So these are the conditions that you need to satisfy, right? So just iterate through the array and check that are these 5 conditions satisfied or not. So basically what you can do is just run a for loop for I equal to 0 to n minus 1. What you can do is, first of all, you increase the frequency of arri. So the frequency of arri plus plus, right? And then you just check for these 5 conditions. That is the frequency of 0 greater than or equal to 3, frequency of 2 greater than or equal to 2, and so on. Like all of these 5 conditions, you will put in if statement. So if this is true, like if fr of 0 greater than or equal to 3, and so on, then you can just print the current index. Like just print I or I plus 1 in one indexing. In one indexing, just print I plus 1, and then you can return. Or basically, you can end this test case. And if you are not able to return, like if this for loop terminates, then you can say that you are not able to make this date, so cout 0 or print 0, whatever. This is pseudocode. So I mean, this condition is pretty simple. So like this is the code also, but I'll just show you the code as well. Okay, so the code for A is this. So I have taken int n cnn, int fr of 10. So fr of 10 is the frequency of all the numbers. Then I have a flag. The flag indicates that which all, like or whether or not I have like found out any number or not, right? Like whether or not I have formed my date. Okay, so I do int x cnx and frequency of x plus plus. So basically I just inputted n first of all, and then in the loop I'm inputting all of these numbers. So I'm inputting this, then I'm inputting this, and so on. So I just take this condition that fr of 0 greater than equal to 3, fr of 1 greater than equal to 1, and all of these 5 conditions I check. And in the end, like if they are all true, and if not flag, that means until now I have not printed any number, then I'll just print the number and I'll set flag equal to true. And in the end, if I don't have flag as true, that means I did not print anything, so I'll have to print 0 because I did not find the condition to be satisfied. Okay, cool. I hope it is clear to all. If you have a doubt, then I will give you 5 seconds or maybe 15 to 20 seconds to ask. Okay, so I am not getting any doubts, so we'll move on to the next one. All right. So the next problem was team training. At the IT campus Newark, there are training sessions in CP, both individual and team based. For the next team training session, N students will attend, and the skill of IS student is given by positive integer AI. The coach considers a team strong if its strength is at least X. the strength of a team is calculated as number of team members into the minimum skill among the team members. For example, if a team consists of 4 members with skills 5, 3, 6, and 8, then the team strength is 4 into minimum of that, so 4 into 3, which is 12. Output the maximum possible number of strong teams, given that each team must have at least one participant, and every participant must belong to exactly one team. All right. So basically, um, we have a problem which says that there are n students. All right. So there are n students with skills A1, A2, A3, and so on up to AN. Right. And let's say we form a team of, let's say, A1, A2, and A3. Then the skill of this team, the skill is defined as number of elements into the minimum element in this array. So whatever is the minimum, multiplied by 3 in this case, because we have 3 elements. So that is the skill level of this team. And what they say is that they have given an x integer in the input, and if the strength of team is at least x, then that team is called strong. Okay. So if the skill is at least x, that is, if the skill is greater than or equal to x, then we call that team as strong. So we have to make the maximum number of teams given the n students skills. So like here we have been given 6 students and their skills, and value of x is 4, and we have to make the maximum number of skillful teams, or strong teams, right? So and we have to print the maximum number. So in this case they are saying that maximum number of strong teams is 4. All right. So in this case, how did they get the answer? Maybe what they have done is 4, 5, 3, 2, 6, right? 4, 5, 3, 3, 2, and 6. So and x is equal to 2. X is equal to 4, right? So maybe one team is just 6. Then one team can be 4 and 5, right? Then what can another team be? Actually, 4 and 5 don't need to be same team, so they can be different team as well. So 4 can be a team, 5 can be a team, and 3 and 3 can be a team, right? So in this case, the strength of this is 6, strength of this one is 4, strength of this one is 5, and strength of this one is 3 into 2, so 6. So these are 4 teams that we were able to form using these 6 students. Note that this 2 wasn't part of any team, but that's fine. So that's why the answer is 4. And it is possible to prove that we cannot make more than 4 teams. Okay. So how do we solve this? First of all, one thing that I would tell you is that, okay, we want to maximize the number of teams, right? We want the maximum number of teams. So we will try that in one team, only like less students are there, right? Like we'll try to reduce the number of members per team, right? Because we want to ensure that there are more teams. So we'll try to first reduce the size, of the team. But that means that we would have to increase the skill, right? Because basically the skill level is what? The number of elements, which is size, into the minimum skill. So if we want to reduce this size, that is, if you want to take less number of teams, less number of students into our team, and we still want it to be at least x, we still want the skill to be at least x, then we would have to increase the minimum thing, right? in that case only this number of elements can we can decrease. So what my point is that we try to take as high as members as possible. Like greedily, we'll try to do that. We'll try to choose a high skilled member, so that the number of members in that team goes down. So like this encourages us to sort the array in reverse order. Like for example, I have this array. So if I sort the array, so 6 5 4 3 3 2, we have 6 5 4 3 3 2. I sorted this array in reverse order. Okay. And then basically we can try to start taking these persons. So let's say I take 6, right? So as soon as I take 6, my currently my team was empty, right? Now I add 6 to my team. So now my team has only 6. So the skill is what? The skill of this team's skill is 6. So which is um greater than x, right? Because x was 2, x was 4, sorry. So this 6 is greater than 4. So therefore we can keep this as a separate team. So this becomes separate team. Okay. Then we have this 5. Just a minute. Yeah, we have this 5. And so, okay, currently 5 is in the team, and the skill of this team is 5, which is greater than 4. So we can keep 5 alone. So 5 alone is also a team. Then again, for 4, this 4 has a skill of 4. So greater than equal to 4, it is like greater than equal to x. So we can keep 4 as a single team. Then we have 3. Um, 3 is not greater than 4, right? Greater than equal to 4, it is not. So we would have to take another element. So let's take this element as well. So now the team becomes 3 comma 3. So what is the strength of this team? It is 3 into the minimum, sorry, 2 into the minimum, 2 into min element, which is 3. So this 6, which is greater than equal to 4. So we'll take these two elements, and finally we cannot take 2. So therefore our answer is just 4 teams. Okay. We cannot take 2 because its skill, like if we have 2 as a team, then that skill will be less than 4, right? So what we'll just do is we'll reverse sort the array and try to take the maximum skilled people, right? And a sort of proof of this is that, okay, when you have sorted um this array in reverse order, then actually you won't ever do something like this. Let's say you take these two people and this one person in a red team, and this person and this person in a green team, or maybe these two persons in a green team. You will never do this. Why? Because actually, okay, first of all, remember that this is in decreasing order, right? So you will never do this. Why? Because it is always better to have contiguous segments. Like instead of this, what you could have done is that you took these three elements and these three elements. So, okay, sorry, green, in green, you will take these three elements. So that is better because in the first case, the minimum for red was this element, but now it is this element, which is greater, right? So that's why you will always take contiguous segments of subarray in a sorted array. So that's why we are greedily, first of all, choosing the highest elements, and then keep inserting elements until we get our score greater than our x, and then that is a team. Okay. So I hope that is clear. If it is clear, then give me a yes in the chat. And if it is not clear, then you can ask it out. I'll show the code as well. Best approach to tackle the problem. Like, I don't know what you mean. This is the only approach to tackle the problem. Like, this is the algorithm, the solution to this problem. Anyways, so I'll go on and show you the code. Okay. So the code for this is something like, I am tracking that. Okay. So first of all, I am doing ln long nx c in nx and input the array a. Okay. So I took the input, then I sorted the array in reverse order. So sort a plus n greater. So this greater sorts the array in reverse order. Then we have last equals -1. So I am keeping two variables. One is count. Count is the number of teams. And this last is the index of the last taken member. Like, basically, let's say I have a team. Like, I have some members. So let's say I took, okay, this is index 0, index 1, index 2, index 3, index 4. So let's say I took these two as my team. So my last would be equal to 1. So when I'm at 3, let's say when I'm at 3, so I will know that I have not taken this 2 in my team. So I'll have to take this in my team. Okay. So last variable is the last element which I have taken. Okay. So I iterate through the array from 0 to n minus 1. So for int I equal to 0, I less than n minus 1, I plus plus. I less than n, I plus plus. If a of I into I minus last. What is this thing? A of I into I minus last. Why have I written this? This is basically, okay, I am at the index 3, suppose, and my last is 1. That means I have taken up till 1. So I have to take 2 and 3, right? And the minimum of this is 3, right? Because this is in descending order. So I'm just doing that a of I. So this is ith. So a of I into I minus last, like the length of this array. So 3 minus 1, which is 2. So a of I into I minus last, if that is greater than equal to x, right? Then I'll do count plus plus. Count plus plus means I am taking this team. So I am making this a team. Okay. And then I'll update last equals to I. And that means that I am taking this I as my last element. Like updating the last as I, right? And finally I just print my count. That how many number of teams I was able to make. What is the answer for 65333321? What is the value of x? X equals 4. Okay, so in that case, 6533321 and x equals to 4. So first of all, you have this 6, then this 5 as individual team, then you have 3 comma 3 and 3 comma 2. So the answer is 4. Okay. Someone asking, what things do I do to improve my skill? Like the only answer to this is practice problems on Codeforces or any other online judges. Like I don't think there's any secret to that. This is the only method to improve. Okay. Okay. Anyways, I hope it is clear. The code is also clear, and I'll move on to the next one. At the IIT campus, Nemark, there are several top secret rooms where problems for major programming competitions are developed. To enter one of these rooms, you must unlock the circular lock by selecting the correct code. This code is updated every day. Today's code is a permutation of the numbers from 1 to n with the property that in every cyclic shift of it, there's at least one fixed point. There is exactly one fixed point. Sorry. That is, in every cyclic shift, there exists exactly one element whose value is equal to its position in the permutation. Output any valid permutation that satisfies this condition. Keep in mind that a valid permutation might not exist, then output -1. Okay. So what do you have here? Basically, the problem in short is like you have been given a number n. Okay. A number n you have been given, and you have to print a permutation like p1, p2, p3 up to pn of numbers. Like a permutation is basically 1 to n numbers rearranged in any order, right? So you have to print any permutation such that in every cycle shift of p, like basically if you shift this p once, so like let's say you shift it towards the right, so what will it become? It will become p2, p3, p4 to pn, and in the end we have p1. Actually, okay, I did it to the left, so I'll change the arrow. So towards the left, if you shift this permutation, you will get this. So this is called cyclic shifting. Like this p1 goes here, okay, and the entire permutation is shifted to the left. So now the index 1 is this, index 2 is this, index 3 is this, index n minus 1 is this, and index n is this. So the problem says that you have to print a permutation, so for which in each cyclic shift there is exactly one fixed point. There is exactly one fixed point. And what is a fixed point? Fixed point is basically any index such that p of I equal to I. Okay. So that's called fixed point. So in each cyclic shift, you want exactly one fixed point. All right. So actually, let's look at samples. Okay. And yeah, if there not exist any permutation, then you print -1. So they are saying that in 4, for n equals to 4, there is not any permutation. So they print -1. Then let's say you have this 5. So they have printed 41352. Okay. So 41352. And so okay, I'll write the indices. The indices are okay, I'll use a different color. Let's say the indices are 1, 2, 3, or okay, let's make a table of cyclic shifts. So sorry. Yeah, so this is the index. The index 1, 2, 3, 4, 5. Okay. So here in this initial permutation, this 3 and 3 are matching, right? Like there's exactly one index for which p of I equal to I, right? Then if you cyclic shift this to the right, then what will happen? You will have 2, 4, 1, 3, 5. So in this case, this 5 and 5 are matching, and no other indexes are matching, and so on. If you do, like, now it will become 5, 2, 4, 1, 3. So here 2 and 2 are matching. Okay. Then if you again shift, it will become 3, 5, 2, 4, 1. So here 4 is matching, and in the end, if you do 1, 3, 5, 2, 4, then in this case, this 1 is matching. All right. So basically, these indices are matching. I am just encircling them, right? So as you can see, that's how it works. So basically, we have to print a permutation which satisfies these conditions, right? So first of all, I look at samples and I saw that for 4 they have given the answer as -1, and for 3 and 5 they have given the answer as something like the answer is not -1. The answer exists. So what I actually guessed was maybe the answer is there for odd but not for even, like n odd but not even. Like I just guessed that. So I tried to make this construction for odd n. Okay, like for if n equal to odd, then I tried to make this construction. All right, so I tried to make it for 5. Like let's say we have 5 blanks and we have 1, 2, 3, 4, 5. Or actually let's do it in zero indexing. So 0, 1, 2, 3, 4. And in our answer also we'll have 0, 1, 2, 3, 4. Just while printing, we'll print +1 of that. So it will become from one indexed. Okay. So now initially what we want is that at least one member of this array should be a fixed point. So fixed point means it should be equal to its index. So let us assume that that number is 0. Like let's assume that 0 is a fixed point. So that means that 0 should be at the index 0. All right. Now where the all of the other elements are, I don't know. But I just know that they are not at their index. Like 1 cannot be here. Okay. Like 2 cannot be at the index 2. All right. I just know that initially 0 is at here. Now what will I do? Now basically in the next cyclic shift, what I want that another element should be a fixed point, right? So let's say I have A, B, C, D here, something, something. Okay, assume that. And I right shift this. So what will it become? It will become something like, okay, this is the index 0, 1, 2, 3, 4. And this will become D, 0, A, B, C, right? So at this point, what we want is that let's say, okay, 0 is done. So 0 was fixed point in the first permutation. But after right shifting it, what we want is another point. That exactly one point should be a fixed point. So let's assume that um, this 2 is a fixed point. 2 is a fixed point. So what does that mean? That A is equal to 2. Okay. Then again, let's try to cyclic shift it. So I'll draw it. So again, if you shift this to the right, then C will come to the front element. So it will become CD0, 2, which was A, and B. And again, you have 0, 1, 2, 3, and 4. So now we have been done with 0 and 2 as the fixed points. So what should I do next? Let's make this 4 next. So 0 to 4. So b equal to 4. Okay. And actually, if you notice that, since I am making this first element as 0, that means that in the other cyclic shifts, it will not be 0. I mean, it will not be at the index 0. Like, see, what I mean is that since we want exactly 1, since we want exactly one fixed point, we are ensuring that we'll get only one. How? Because in the first cyclic shift, we have made 0 as the fixed point. So when we are shifting this array to the right, like this, then what will happen is 0 can never reach again to this index. Like 0 has already moved forward and up, it will reach up to here only. Like if it reaches back here, then it is the same permutation as this one, the starting one, right? So it can never happen that 0 is a fixed point ever again in our permutation. So at each step we are ensuring that whichever element we are choosing to be a fixed point, it will not be a fixed point in any other permutations. So that's why we'll have exactly one fixed point in each iteration, in each of the combinations, right? So here we chose 0 abcd, then we shifted, so we have d0 abc. So a equals to 2 we set, like we try to make this as a fixed point, and we know that 0 is not a fixed point because it was fixed point in the previous one. Then we again shift it, so it becomes cd0 2b, and here we choose 4 to be our what fixed point, right? So basically now it becomes cd024. Now again if we shift this, it will become 4 cd02, where the indexes are 0 1 2 3 and 4, right? So now what we can do is, let's say c is 1, like let's put c is equal to 1. So c becomes 1, so I'll just write it here, right? And then I will again right shift this. So what will it become? It will become 2 4 1 d and 0. So we have only one choice of d. What should we put it? We have to put it as 3, right? So we put it as 3. Okay, so it becomes 2 4 1 3 0. So in the end, if you see that basically we had started with 0 abcd, then we set a to 2, we set a as 2, we set b as 4, we set c as 1, right? But in the pattern, if you see, it should have become 6, right? Like 0 2 4 6 and 8. But actually what we did, we put c as 1 and d as 3, and that's because like we can kind of observe that it is just mod 5. Like since we are cyclically shifting it, the mod n comes into picture. Like basically, if you have shifted the array a I times, then your current arr of j becomes arr of j plus I mod n. Like cyclic array, I hope everyone knows here that you just take mod n, so it becomes cyclic array. So here also, since you are cyclic shifting it, you can try to observe the pattern that we are putting 0 2 4 6 and 8 and taking them mod n. So I'll write it cleanly here that first of all we have these 5 indices, uh, 0 2 0 1 2 3 4, and at the index I am putting 2i mod n. right? 0 to 4. um then 2 into 3 is 6 and mod 5 is 1, and 4 into 2 is 8, mod 5 is 3. So hence you will see that this satisfies your cyclic shifting. Okay, someone else is saying that just put in reverse. Yeah, that is also fine. Basically what you are doing is just print 5 4 3 2 1, right? So like in this case it is 3. Then if you shift this, so it becomes 1 5 4 3 2. So now this is a fixed point, and if you shift this, so it becomes 2 1 5 4 3. So this becomes 6 point, and so on. Yeah, that is also a solution. And this one also works for only odd numbers, as I can see, because for even numbers if you try, let's say 4 3 2 1, then there is no fixed point in this one. And also if you try this approach for even numbers, that 0 2 4 1 3, like basically 0 into 2 1 into 2 2 into 2 3 into 2 modern, and 4 into 2 modern, that also does not work for even numbers. Let's try that. Like let's say n equal to 4. So um, 0 0 1 2 3. If I do 0 into 2 modern, 1 into 2 modern, 2 into 2 modern is again 0, and 3 into 2 modern is again 2. So this is not a permutation, right? So that's why it doesn't work for even indices. So like my strategy of creating these cyclic shifts using this mod operator, that doesn't seem to work in even numbers, and actually that's why I just submitted it, assuming that it doesn't work for even numbers, and it got accepted. Like, but I don't have actually the proof. I don't have the formal proof that there is no permutation for even numbers. So, but I have this intuition that this construction doesn't work for even numbers. So it shouldn't, like, it is not possible for even. Like basically just guessed. I don't currently have the proof for why does it not work for even numbers. Okay. Or like for odd numbers, more formula you can say that, let's say AI basically, for I equal to n to n, I equal to 0 to n minus 1, you had the array as AI, like ith element had AI position. So when you shift this cyclically, it will go to a of I plus 1. Like it will become a of I plus 1 will become AI, right? So when you shift a of I plus 1 I times, it will become like a of I plus I, which is a of 2I. And if you want that this a of I is a fixed point at the ith cyclic shift, then this a of 2I has to be equal to I. Like more or less this is the thing, this is the way, like why is my way working. But yeah, even printing the reverse thing is also fine. Okay, anyways, so I hope it is clear. So I'll wait for 30 seconds for any doubts, and just 1 second. Yeah, all right. So what I was saying is that that's how you can like construct this permutation. All right. So if no one has a doubt, then I'll move on to the next one. Okay. So the problem D says for the final of the Olympiad by IT campus Nemark, a rectangular venue was prepared. You may assume that the venue is divided into n rows, each containing m spots for participants' desks. A total of k participants have registered for the final, and each participant will sit on an individual desk. Now, organizing committee must choose the locations for the desk in the venue. Each desk occupies one of the m spots in a row. Moreover, if several desks occupy the consecutive spots in the same row, we will call such a row of desks as a bench. And the number of desks in the group is the bench's length. For example, seating 7 participants on a 3 by 4 venue can be arranged as follows. Like you have 3 rows and 4 spots in a row, and you can make like 7. You can seat 7 participants in this way, like in the green way, right? In the above, the first row has a bench of length 3, the second row has a bench of length 2, and the third row has 2 benches of length 1. So the bench is basically the maximum contiguous portion. The organizing committee wants to choose the locations so that the length of the longest bench is as small as possible. In particular, the same 7 desks can be arranged in a more optimal way so that lengths of all benches do not exceed 2. Like here, they had one bench with length 3, but it is possible that none of the benches exceed 2 length in this way, right? So, given the integers n, m, and k, determine the minimum possible length of the longest bench. Okay, so like the problem should be clear that basically and we had a grid. All right. Basically, what we have a grid of n by m. Okay, so in let's say n equal to 4 and m equal to 4. So we have these 4 rows and 4 spots in each row, and a bench is called that. Let's say if we seat 3 persons in the same row and contiguously, so it is called a bench of 3 persons. So if 3 persons are sitting in all of these 3 spots, then it is called a bench of 3 row, and we want to sit k persons. We want to seat k persons, and we want to minimize the length of the maximum sized bench. All right. So yeah, that is the problem. And how to solve it? Let's see. So okay, 3 4 7. The answer is 2. because that was just the sample, like that was the explanation, that for 3 rows and four columns or 4 spots and 7 people, you can arrange it like this, and you will have no more than two sized benches, right? And you cannot do it in one size benches. Why? Because let's say you had 3 by 4, 1 2 and 3, 1 2 3 and 4. So let's say you had uh, this, and you wanted that no two contiguous had like are together. So basically you want bench of only one length, so you can only do it like this, right? This, so because you cannot color two adjacent in the same row, so at max you can only color 6, but you have to seat 7 people, so therefore you will have at least two length benches. So that is a valid coloring. This coloring is a valid coloring. All right. So how do we find out? So basically, just appreciate that what is happening in this scenario. Okay. So actually, if I tell you that, let's assume that I ask you a question, that is it possible to seat like 7 people in 4 by 3 by 4 grid with bench size equal to 3, let's say. So like if I ask you this question, that is it possible to seat 7 people in 3 by 4 matrix with bench size, with maximum bench size equal to 3, then will you be able to answer this question? Or let's say I make it a bit bigger. Let's say we had 10 by 10 matrix, and we want maximum bench size to be only 3. So can you fit let's say 60 people in a 10 by 10 matrix with only 3 bench size? So is that possible? So how do we determine that? We'll just try to put all of these benches and calculate, like, and count that how many are we able to put. Okay, so let's assume that, okay, 1 2 3 4 5 6 7, so 8 9 10, 8 9 and 10, right? And just assume that I have 10 rows. I might have less in this diagram, but just assume that I have 10 rows. Okay, now let's say in the first row I want to have length 3 benches. So obviously I will keep a bench at the corner, right? So now this is a length 3 bench, right? And now I cannot keep one here. I cannot keep one bench here, because in that case it would become length 4. Just a minute. Yeah, so if I take this one, then it would become length 4. So I cannot take this one. And again, I'll take 3 from here. And again, I cannot take this one. But then I can take these two. Right? So basically, you are able to fit, like out of 10, you are able to fit 8 people in one row. So 8 people in one row, and total you have 10 rows, right? So total 80 people you will be able to fit. And how many you want to fit? You only want to fit 60 people. So the answer to this would be yes. Right? So it is possible to select 60 people or 60 benches or 60 cells in order to form maximum bench size equal to 3 or less than equal to 3. Right? So how will you do it in code? Like, what is the condition for this? Basically, you will do that n into the number of benches or the number of people in one row. Number of people in one row. But how will you find that out? The number of people in one row? Basically, if you have a size m row, right? You have this row of size m. There are m cells. Okay. There are m cells, let's assume. And you want to fill in with maximum bench size of k. So, okay, so let's say the maximum bench size is k. Or not k, let's say it is some mi or ma maximum, right? So what will you do? You will fill ma cells and then you will leave one cell. So in total, these are ma plus 1 cells. So you will keep doing this, that you will fill these cells and leave one cell. Then you will again fill ma cells and leave one cell. So again you will have ma plus 1 cells. So you will do this until there are less than these number of cells in the end. So like here, what did you do? You filled these 4 cells, then you filled these, like you did not fill these 4, but you filled these 3 and then skip this one. Then you did the same with these 4. But now in the end, you have less than 4, right? You have only 2. Or what you can say is, basically you have divided 10 by this 4. So you get 2. Like taking the GIF, you get 2. So basically you can do this filling thing 2 times. And the number of remaining is just 10 mod 4. So that is also 2. So in the end, you will get like 2 cells remaining, and those 2 you can fill with the green color. So again, you will fill MA with green and then skip one. Then again you will fill MA with green, then skip one, and so on. So in the end, what you have is M upon MA plus 1. These many number of cycles filled, and in the end, okay, so these number of cycles are there, and in each cycle there are ma number of colored cells, right? That out of ma plus 1, ma cells are colored. So in each cycle ma cells are colored, so you will multiply this by ma. So these number of cells are colored, and then in the end, whatever the remaining cells are, you can color them as well, right? So you will add m modulo ma plus 1, right? So the number of this is the number of people that you can sit in one row, right? And if you have n rows, so you will just multiply it by n. So if your maximum bench size allowed is ma, then these maximum people you can fit on your board, right? So but this is not what we have to do. Like, our problem was that we have to fit k people. So what is the minimum bench size that we require? But what we have answered is that given a bench size, what is the maximum number of people that we can handle? So how do you solve this problem using this fact? How do you solve this? You can actually do binary search and answer. So like basically here we have 3 4 7, right? That n equals to 3, m equals to 4, and k equals to 7. And we want to figure out that what is the minimum possible number of bench length that I need, right? So what we can do is we'll try different bench lengths, right? So first of all, you try bench length 1, right? So you plug in ma equal to 1 and n equal to 3, m equal to 4 in this formula, and that will come out to be less than 7. Like that will come out to be 6, right? Because I had showed you here that it is 6. So it is 6, right? So that is less than 7. So you cannot do it with just one bench length. Then you check for two bench length. So for two bench length, it comes out to be something else. It comes out to be, I think, 9 or something. So that is greater than equal to 7. So that's why you can do it with two bench length. But instead of doing a linear search, that okay, we check for 1, we check for 2, we check for 3, we do a binary search, right? Because it is monotonic. Basically, if you keep increasing the maximum bench length, the number of people that you will be able to accommodate, that will also increase, right? Because it is getting more and more tightly packed then. So actually, personally, what I did was binary search. Now it is possible that some of you might have come up with a closed form formula for this, and that's okay. But I think the binary search is pretty simple of a solution, right? So basically, for 1, it is false that you will not be able to seat 7 people with 1. Then for 2, it is true. Then for 3, it is true. For 4, it is true. So this is the monotonic, and you have to find the first true. So you will just do binary search answer, where the lower limit is 1. Lower limit is 1. That maybe you are able to do it with bench length equal to 1, and the upper limit is basically m, that you are able to do it only while filling the whole row. So like in case k is equal to mn, so that means you would have to fill the whole row, right? So in that case, you would need bench length equal to m, right? So low equal to n and high equal to n. So finally, the TC of this approach would be just log m, like log of high minus low, which is O of log m. Because the check function is O of 1, your check function is just this expression, whether it is greater than or equal to k or not. So this is just O of 1 operations. So total time complexity is log m. Okay. So I hope it is clear to all. The logic is clear. If it is clear, then you may or may not write yes. But if it is not clear, then you may write what's your doubt. Okay. So I hope that it is clear to all, and I'll move on to the next one. All right. So we have problem number E now. Interesting ratio. Recently, Misha at the IT campus Nemark camp learnt a new topic. the Euclidean algorithm. He was somewhat surprised when he realized that A into B is equal to LCM into GCD, where GCD-AB is the GCD and LCM is the LCM. Misha thought that since the product of LCM and GCD exists, it might be interesting to consider the quotient LCM upon GCD. For example, he took A equal to 2 and B equal to 4, and he computed f of 2 comma 4, which is 4 by 2, which is 2, and obtained a prime number. Right. Now he considers f of a comma b to be an interesting ratio if a is less than b and f of b is a prime number. Since Misha has just started studying number theory, he needs your help to calculate how many different pairs of numbers a and b are there such that f of ab is an interesting ratio and 1 less than equal to a less than b less than equal to n. Right. Okay, but before this, actually, I forgot to show the code for D. So I'll do that for you all. The code is pretty simple. We just take NMK, C and NMK, low equal to 1, high equal to n. While low less than high, LL mid equals to low plus high by 2. Right? And we check for mid. That if n into this whole thing. So this is the number of items per row. So mid into m upon mid plus 1 plus m modulo mid plus 1. If this whole thing is greater than equal to k, then we do high equals to mid. Otherwise, we do low equals to mid plus 1. And then we print low. Alright. Anyways, so we were doing E, right? So, yeah. The problem E was this. And what we have to do is that, so basically we have been given an integer n. Okay. And we have to count the number of pairs a comma b such that they are between 1 and n and a is less than b and LCM of a comma b upon GCD of a comma b is equal to a prime number. Right? That is what we have to do. Now, let's say that that prime is p. Okay. Then how do we solve this? So, okay, let's look at the LCM and GCD prime wise. Like basically, if we factorize a, then it would be something like p1 to the power a1, or maybe p1 to the power alpha 1, p2 to the power alpha 2, p3 to the power alpha 3, and so on, pk to the power alpha k. And if we factorize b, it will be similarly it will be something like p1 to the power beta 1, p2 to the power beta 2, and so on and so forth. So if we look at it prime by prime, like let's say we look at p1. If we look at p1, then in the LCM of a comma b, what is the power of p1? Like if in a the power of p1 is alpha 1 and in b the power of p1 is beta 1, then in LCM of a comma b, what is the power of p1? It is the max, right? The max of alpha 1 comma beta 1. Why? Because let's say for example we have 8, which is 2 cube, yeah, which is just 2 cube, right? And we have, let's say, 12, which is 2 square into 3. So there in their LCM, the power of 2 will be 3 because it is the bigger one of both. So in the LCM, the power of P1 is max alpha 1 comma beta 1. And in the GCD, in the GCD of A comma B, it will the minimum. It will be the minimum of alpha 1 comma beta 1, right? So now, like in the ratio, the power is a difference. So the power above is maximum, the power below is minimum. So max minus min will happen, right? The power of prime p1 in this ratio will be max of alpha 1 minus beta, alpha 1 comma beta 1, minus min of alpha 1 comma beta 1, right? So this is the power of p1, right? But what we want is that this ratio should be equal to some prime to the power of 1, right? It should be some prime to the power of 1. So that means that my max minus min should be equal to 1. Now let's say alpha 1 greater than beta 1. Alpha 1 is greater than beta 1. So that means that alpha 1 minus beta 1 should be equal to 1. Right. So that means the power of prime p1, if that is something a, or there is something k in a, and if it is like if it is k minus 1 in b, then in LCM upon GCD its power will be 1, right? So that's what we want. But one more thing to notice is that we don't want this for every prime. Like, see, we want that only one prime's power should be 1, and all the other prime powers should be 0. So p1 to the power 1, but p2 to the power 0, p3 to the power 0, and so on, because we want this to be prime, right? We want this whole number to be prime. That means that we should have only one prime factor in this ratio. So that means in a and b, the power of p1 should be k and k minus 1, so that the power of p1 in the ratio is 1. But for other primes, p2, let's say p2, we want its power to be 0. That means that alpha 1 minus beta 1 should be equal to 0. So that means alpha 1 or alpha 2, let's say alpha 2 minus beta 2 should be equal to 0. So alpha 2 should be equal to beta 2. So that means that the power of other primes other than p1, it should be the same in a and b. Alpha 2 equal to beta 2. That means the power of p2 should be same in a and b, right? So what we have till now is that, okay, we have p1 to the power k. Like if I write a, this is p1 to the power k, or p1 to the power k1, p2 to the power k2, and so on, right? So in b, what I would have to I would like to have is that the power of p1 should be k1 minus 1, and all the other powers should be same. So power of p2 should be k2, and so on. So in a comma b, what can we say? We can say that a is just b into p1. Okay, that's the thing. That this is the sufficient condition, that a should be b multiplied by some prime, like any prime this can be. So all of the pairs that are of this form, that basically a comma b pair, or let's say b comma a, because we want, basically what I say is that a should be b into p1, right? So all of the pairs a comma b will satisfy this condition, where p1 can be any prime number. They will satisfy this condition of LCM by GCD equal to p1. and no other pairs will satisfy this condition. So in summary, what we want is the number of ordered pairs a comma ap, where a is any number and p is a prime. So all of the pairs of this type will satisfy a condition. So our problem boils down to finding the number of pairs of the form a comma ap such that 1 is less, like a greater than equal to 1 but less than ap and less than or equal to n, right? That's our entire problem now. And this 1 less than, like a greater than equal to 1, that is pretty obvious, it will happen. Like we want a greater than equal to 1, okay, that is one constraint. So I'll write it like separately, that we want a greater than equal to 1. And also here it was a less than ap, so that was by default it will happen because p is a prime, so p is greater than equal to 2, so I don't have to write that. uh, okay, 1 minute. Yeah, so I don't have to write that, so I'll erase that. And finally I want ap less than equal to n, right? So I have these two conditions. First condition is a greater than equal to 1, and second condition is ap less than equal to n. And if I write this in another way, I want that a should be less than or equal to n by p. Okay, and a greater than equal to 1. So what does that mean? That the number of values of a, like for a given p, the number of values of a, how many are there? Total n by p value are there, like from 1 2 3 up to n by p, the floor of n by p, right? So for some p, the number of ordered pairs of type a comma ap, it is n by p, because we can take a equal to 1 or a equal to 2 or up to a equal to n by p we can take, right? So up till here, is it clear to everyone? If yes, then just write a clear in the chat. Okay, I think it is clear to all. So now essentially the problem boils down to, we have to basically iterate over all the primes and add the sum of n by p, right? Like let's say n equals to 7 for example, or n equals to 8, let's say. So if we want to solve for n equal to 8, that a comma ap pairs where ap is less than or equal to n, right? So either p can be 2. If p is 2, then a can be 1, a can be 2, a can be 3, a can be 4. Then if p is 3, then a can be 1 2, it can't be 3, right? So okay, if p is 5, then a can be only 1, and if p is 7, then a can be only 1. So basically what we can do is just iterate for over all the primes p, like 2 3 5 7, and just do n by p. So n by 2 plus n by 3 plus n by 5 plus n by 7, and so on, up to whichever prime is less than n. As soon as the prime is greater than n, you will terminate the loop. So that is the final answer. And how do we actually implement this? That is also a question, because n is up to 1 is 7, right? So if you try to naively implement this using maybe square root n time to check if a number is prime or not, then it will give TLE. Okay, like let's say you just iterate over 1 to n, and for each number from x, you check that if it is prime or not. In square root of x time, you check, and if it is prime, then you add n by x to your answer. But this will give TLE because this is just n root n time complexity, and that definitely will not pass. So what we can actually use is, we can actually pre-compute all of the prime numbers using a sieve. Using what? A sieve we can use. If you don't know about the sieve, then I highly recommend you to learn about it, and it is because it is very useful in CP problems. All right. Summarize. So till when, till where did you get? Like, did you get till here that we want all the pairs of the form a comma ap? Like, the wonderful thing about YouTube is that you can actually rewind a video and see it one more time. So I recommend you to do that. So anyways, I was saying that you can pre-compute all the primes. All primes up to 1 is 7. And it will take time O of n log n. Like, it is very fast, where n is 1 is 7. So you can just pre-compute all the primes up to 1 is 7. And then you can just iterate over them. So that will take only O of n time. And in fact, not even n, it will be number of primes less than n. So I just write it as approximately O of n. Actually, it is n upon ln n. That number of primes less than or equal to n are approximated by n upon ln n, which is a natural log of n. I mean, this is one fact that you might want to know. So anyways, what we are doing is just pre-compute all the primes up to 1 is 7, and when you get n as an input, just iterate from all the primes. Iterate all the primes from 2, 3, 5, 7, and so on up to the last prime, which is less than n or less than equal to n, and just add n by p to your answer each time. So this will take the time of whatever the number of primes less than equal to n are. All right. So I hope it is clear to all. If it is clear, then I'll show you the code. All right. Yeah. So the code is, so here actually I pre-computed sieve. Like, this is the code for the sieve. Okay. So basically, this entire loop, these two loops, pre-compute the sieve, and these make two vectors. Like, one vector is vector of int primes, which is a list of all primes up to 1 is 7, and this is a vector of bool, which is prime, or boolean array, which is called is prime, which stores that if I is prime or not. Okay, so we can use this array of primes and iterate over it. So what I did was int n, c in n, ll ans equal to 0, and then I just iterated from I equal to 0 I less than primes dot size, and primes of I less than equal to n, and I plus plus. So as soon as my prime becomes greater than n, I break. So ans plus equals n by p, n upon primes of I, and see out ans. Okay. So I hope it is clear to all. If it is not clear, then you may want to um, leave a chat. You may want to ask any doubt. Like if you have a very particular doubt in my explanation, then you can ask. Otherwise, maybe you can try rewatching. And if you still don't get it, then you can make a comment on the YouTube video. Okay, so I think it is clear. So I'll move on to the next problem. Okay, so this is the final problem of the day, and it is called Igor and Mountain. So the problem says that the visitors of the IT campus Neymark are not only strong programmers, but also physically robust individuals. Some practice swimming, some rowing, and some rock climbing. Master Igor is a prominent figure in the local rock climbing community. One day, he went on to a mountain hike to ascend one of its peaks. As an experienced climber, Igor decided not to follow the established trails, but to use his skills to climb strictly vertically. Igor found a rectangular vertical section of the mountain and mentally divided it into n horizontal levels. He then split each level into m segments using vertical partitions. Upon inspecting these segments, Igor discovered convenient protrusions that can be grasped, hereafter referred to as holds. Thus, the selected part of the mountain can be represented as an n by m rectangle with some cells containing holes. So this is the scene that basically he has a wall. Okay, he has a wall, and these x are the parts which he can hold. Okay, and hashes he cannot hold. All right, and he is climbing a rock. So initially he is at the bottom, and he has to one by one climb to the top. Okay, so being an experienced programmer, Ego decided to count the number of valid routes. He has to count the number of valid routes. A route is defined as a sequence of distinct holds. Distinct. So you cannot repeat a hold. A route is considered valid if the following conditions are satisfied. The first hold in the route is located on the very bottom level, row n. So in the last row, it should be the first. The first hold should be in the last row. So we have to start from the last row. Okay. The last hold in the route is located at the very top level, the row 1. So we have to end at the top level. Each subsequent hold is not lower than the previous one. So basically, we cannot go down. Like as soon as we are here, we cannot again go down here. Okay. At most, two holds are used on each level. So basically, we cannot do something like um, we like go here, then we go here, like on this one, and then we go here. Or basically, we cannot move on the same level for more than two times. Each on each level, there have to be at most two holds. Igor can reach from the current hold to the next one if the distance between the centers of the corresponding sections does not exceed Igor's arm span. So basically, Igor's arm span is there, that it is d, which means that he can move from one hole to the other if the Euclidean distance between the centers of the segments does not exceed d. The distance between sections I1 J1 and I2 J2 is given by square root of this. So the normal distance formula that we have. So basically, he can go from one cell to the other if and only if there is an x on that, like if and only if there is an x on the final square and the initial square, and also his arm span is large enough. So if it is larger than, if the distance is larger than d, then he cannot move to that cell. Okay. Calculate the number of valid routes. Two routes are considered different if they differ in the list of holds used or in the order of which these holds are visited. Okay. Akshat, you can rewind the video and just see. Okay. So yeah, the problem statement was very convoluted, but we read it. So basically, it says that we have to count the number of paths from the bottom to the top, and the path has to be on the axis only, right? And there are more conditions that we cannot jump. Like we cannot jump from this here to here. Like we have to go step by step from here to here to here. And also we can move in a row as well. So like we can move from here to here to the left one. But we can do that only once. Like the route should not have the same row more than twice, right? So that's the thing. And we have to count the number of paths. So let's say in the first test case, the M and N is given to be 3 and 4, and D is given to be 1. Okay. What does it mean by at most two holds? At most two holds mean ki holds is this, like this X is called a hold because that person can hold this X and move forward. So like he is climbing a wall and he can hold this X. So all of these X's are holds. So in our route, in our route, there has to be at most two X's of the same row. Like we cannot have more than two X's in the same row. Okay. Yes, in one level, you can do max one parallel jump within that level. Yes, that is true. That's what it means. So okay, in this test case, um, his arm span is one, so he can only jump if the distance is one or less than one. So it can be less than one. It has to be one. Okay. So let's say he starts at the bottom from here. From here he can go here. From here he can go here. So that's one path because he reached the top, right? But one more path is there that from here he can, like he starts at here, then he goes here, then he goes here, and then he goes here, like the parallel. So he ends up at here. So this path is also different. So that's why there are two different paths in this. Now, what is not a valid path? Let's say he starts here, then he cannot go to here because this is root 2 distance away. This is square root of 2 distance away, like square root of 1 square plus 1 square. So square root 2 distance away it is. So and his arm length is only 1. So he cannot go there, right? And also let's say if you go from here to here to here, but now where you will go? You cannot go again here because you have already moved once in the same row. So from here you cannot go anywhere, right? So therefore there are only two paths in this test case. And in this test case there are 30 paths or 60 paths. So I won't count all of them obviously, but we'll know how to like write the code. So this is basically a pretty simple DP problem. Okay, so I think many people who have done DP should be able to recognize that this is a DP problem. That find the number of paths from vertex A to vertex B and so on. So that kind of problems are almost always DP problems. So like here our state, what would be our state? Our state can be like DP of IJ. DP of IJ is the number of paths which end at the vertex I comma j, like at the row I in the column j, right? So from ij, where can we go? Like from ij, either we can go up, so we can go I minus 1 to some k, right? Because up is I minus 1. We are going from I to I minus 1. And from j to some k we can go, such that the hand span, like the distance between these 2 points, should be less than or equal to d. But also we can stay in the same row. Like we can say we can stay at I comma k, like for some k, such that the distance between these 2 points is less than or equal to d. But the thing is that what if we try to again move from I comma k to another I comma l, for example? Like this is not allowed, right? This is not allowed. That we cannot move twice. So actually we also have to keep track of how many times we have moved in the current row. Like if we have already moved once, then we cannot move it again. So I'll add another state to my DP. Okay. So another state to my DP is that DP of I, J and K. So what is I, J, K? Here K can be only 0 and 1. Okay. So ij 0 means like dp of I comma j comma 0. It means that I have reached I comma j from somewhere bottom. Like I have reached them. I have reached I comma j from I plus 1. I plus 1th row. Or basically what I mean to say is I am able to move parallelly, like to I comma k. But now I'll move to I comma k comma 1 because I have already moved once. So basically, from this state, I cannot go to I comma L because I am already at 1. So that's why I am keeping on one more state of whether or not I have already moved in the current row parallelly or not. So from I comma j comma 0, I can transition to I comma k comma 1, or I can transition to I minus 1 k comma 0. And from I comma k comma 1, I can transition to some I comma L comma 0. Okay. And for each DP, I'll just store that how many number of paths are possible. Right. So I hope this one is clear till now, that what is my state. My state is the position and also whether or not I have already moved in the current row. So is it clear till here? Is it clear? Okay. So now that we have the state, let's think about transitioning. Okay. So just 1 second. I'll just see whether I have pulled or pushed. Okay, so I have done a pull DP. Uh, yeah, okay. Anyways, so okay. So let's say I want to calculate DP of I J 0. I want to calculate this DP I J 0. That means I am at the row I and the column J, and I have not yet moved in the same row. So what does that mean? That means that I have come from the bottom and moved to the top. That sounds like a story. But anyways, so let's say this is I comma j. So here I comma j comma 0 means that I have come from the bottom row. This I plus 1th row I have come from, and from some cell, like from some cell I have come, right? And from which cells could have I come? What all cells are possible from which I could have come? Like currently I am at I comma j, and I could have come from I plus 1 comma k if the distance between these 2 points is less than or equal to d. So what's the distance? Distance is basically square root of 1 square plus j minus k whole square. And if this is less than or equal to d, then you can transition from I plus 1 comma k to I comma j, right? And also it has to be that I comma j has to be equal to a cross, like there has to be a hold there. If there is a hash there, then the dp is just 0. We cannot move that, like we cannot move to that state, so the number of paths ending in that state is 0. Okay, so anyways, if it is cross, then we can transition from I plus 1 comma k to I comma j if and only if this holds. So let's simplify this. This means that j minus k whole square is less than or equal to d square minus 1. So absolute value of j minus k should be less than or equal to root over d square minus 1. Let's call this value as sq, like, or something. This is a variable sq. So absolute value of j minus k, which is same as k minus j, is less than or equal to sq. So I can say that my k should lie between j minus sq up to j plus sq, right? This is the thing, correct? And now what I have to do is basically transition from all of these states. Like basically all of these k are valid, right? I can transition from I plus 1 comma k to I comma j for all of these k, right? So basically I have to do that dp of ij0 plus equals, okay, yeah, and another thing, I can transition from both the 0 states and 1 states of these. So I can transition from both dp of I plus 1 k 0 or dp of I plus 1 k 1. Like I can transition from both of these, right? So basically what I have to do is I have to add that dp of I comma j comma 0 plus equals dp of I plus 1 k comma 0 plus dp of I plus 1 k comma 1, and we have to make a for loop for k in this range. We have to add this transition, we have to do this transition, but the thing is that this is too slow. Like basically we have, how many states do we have? We have n into m into 2 states, right? Wait, yeah, here we have n rows, m columns, and 2 states, so we have 2 mn states. And here, to transition, I am running a for loop of size 2sq. So 2sq can be actually pretty large, or basically min of 2sq comma m. Like if 2sq is pretty large, then we can choose all of the m cells. So it is basically O of m. The transition time for this strategy is O of m. So the total complexity would be O of n into m square, which is actually too slow, because here the limits of n comma m are up to uh, like 2000, right? So what to do now? Can anyone guess, or can anyone reduce till now? Actually, what you have to do is here, you have to basically calculate the range sum, right? Like, let's say we had dp of I plus 1 comma k comma 0. So if this k is a parameter, like just assume that this dp of I plus 1 comma 0 is an array and k is the index. So in that array, you have to perform a range sum for k in this range, right? Do you all get it? Like, if I know the range sum of this dp from this k to, like, from this number to this number, k belongs to this range, then I can just add it. I can add the entire thing to my dp of ij0. So yes, I can use range sum query. That is, I can maintain a prefix sum. Like, basically, I want to transition from I plus 1, right? So, like, I have already processed I plus 1. So see, I have this grid, right? And I am moving from bottom to top, correct? So let's say when I am at this point I comma j, I have already calculated the dp's of all of these cells. So what I can just do is take the prefix sum of this row, right? And then whatever the queries you want to ask, you can just do range sum. Like, for every cell I comma j that you want to transition from, you can just take the prefix sum and do a range query. Like, you can just do p of r plus 1 minus p of l. Like, this is what range sum is, right, in prefix sums. Like, if I define my prefix sum like p of I is equal to a0 plus a1 plus up to a of I minus 1, and I define my p of 0 as 0. So in this case, my range sum from L to R, that is just p of r plus 1 minus p of L. So if you just calculate, first calculate the dp, like first calculate the dp of this row, and then calculate the prefix sum of this row, then you can easily and efficiently transition from this row to this row, right? So here, what I'm doing is, for k in this range, just add dp of I plus 1 k0 to this dp, and dp of I plus 1 k1 to this dp. So this is taking O of m time. But instead of doing that, I can just do a range sum on dp of I plus 1 comma 0 and a dp of I plus 1 comma 1. And that's how I can update this dp of I comma j comma 0. Alright. So yeah, so basically I had told you that, okay, if I want to transition to I comma j comma 0, in that case, I would have like have I plus 1 comma k comma 1, or I plus 1 comma k comma 0. From these two states I can transition, right? But what if I want to transition to I comma j comma 1? So I comma j comma 1 means I have already traversed once in this row. Like horizontally I have traversed once. So ending up at I comma j comma 1, it means that currently I'm at I comma j, and I have come there from I comma k, right? And again, I can do this if my distance is less than equal to d. So distance between I comma j and I comma k, which is mod of j minus k, that should be less than equal to d. So all the points, and yeah, I can transition there from I comma k comma 0, right? So I have to transition to I comma j comma 1 from I comma k comma 0. So basically, first of all, calculate all of the I comma k comma 0 ones. So basically, I comma k comma 0 ones depend on I plus 1 comma k comma 1 and I plus 1 comma k comma 0, right? So just calculate all of the I comma k comma 0 ones and then take a prefix sum again. Okay, because here also you want that this is the range of k, right? So k belongs to uh, j minus d up to j plus d. So in this range you want the sum of the dp. So for that, first calculate I comma k comma 0 dp and then take the prefix sum of that. And then to calculate I comma j comma 1 dp, just take the range sum of k from j minus d to j plus d, right? It is that simple. And finally you have to reach at the top, you have to end up at the top. So your final answer would be just the sum of these dp's, sum of all these dp's, both type 0 and type 1, they are fine. Like even if you end up and you have made a move in the same last row, then also that's fine. So the sum of all the dp's of type 0 and type 1, that is your final answer, because that is the number of paths ending in that cell, and you can end up at any cell in the top row, right? So I hope that it is clear. Is it clear, guys? Okay, since I am not getting any doubts, I am assuming yes. Just tell her how to calculate range sum. Range sum, like it is pretty basic. Like prefix sum you can take. Basically, if you have an array A, which is A0, A1, A2 up to A of n minus 1, then let's say you have to calculate the range sum from L to R. That is, you want to calculate AL plus A of L plus 1 up to AR. And you have like Q queries of this form. Then you can make a prefix array. Like you can pre-compute a prefix array which is like P of 0, which is 0. P of 0 is 0. P of 1 is A0. P of 2 is A of 1, A of 0 plus A of 1. Then P of 3 is A of 0 plus A of 1 plus A of 2, and so on. So if you want this sum, you can just take the prefix of R plus 1, which will have 0 to R, A of 0 to A of R, and subtract A of 0 to A of L minus 1, which is P of L. So that is prefix sums. For DP I was asking. Okay, Akshay is asking that why can't he skip two rows if his arm span allows? Actually, it is because the rules say so that each subsequent hold, no, sorry, uh, yeah, at least one hold is used on each level. So this is the rule. That's why we are not considering that he skips one level. Christopher Henry, for DP, I was asking. For DP, what were you asking? Like the transition are like for DP, ij0. Suppose you want to transition into this, you want to calculate this, then it is just prefix sum. Like basically, in if I write in summation form, it is basically k equal to j minus sq to j plus sq of dp of I plus 1 k 0 and plus I plus 1 k 1 as well. So summation k equal to j minus sq to j plus sq dp of I plus 1 k and 1. So you can calculate these two sums efficiently using prefix sum. Like whenever you are calculating this dp of I plus 1 k comma 0, like what I'm saying is you are moving upwards, right, in the matrix. So let's say you are done calculating this row, you have calculated the dp0 of this row, so just calculate the prefix sum of that, so you can use that in the next row's calculation, the prefix sum. All right, and the same thing you can do for dp of ij1, dp of ij1 transitioning from I comma, like transitioning from dp of I comma k comma 0, like in the same row, if you move then it is from 0 to 1, right? That's why. So again you need a prefix sum for this 0. All right, so I hope it is clear. All right, so I'll show the code. uh yeah, so I have this modular int class actually, which takes the mod automatically, so I don't have to worry about it. So int nmd scene nmd modular int dp. So dp of nm represents the number of ways to reach n comma m, or dp of I comma j, number of ways to reach I comma j, right? String s of n. So this is the input matrix, right? Now this is the base case for int I equal to 0 I less than I plus plus. If in the last row the ith is x, then I'll do dp of n minus 1 I comma 0 is 1, because there is one way to reach there, that is the start from there, right? Then I have prefix sum, like this prefix sum array is the prefix sum along this m parameter. Okay, so prefix sum of n minus 1 I plus 1 comma 0 is prefix sum n minus 1 I comma 0 plus dp of n minus 1 I comma 0. So basically I have calculated the dp0 for last row, right? This is the dp0 for last row, so I am just taking its prefix, and the dp1 for last row I am calculating here, right? So if s of n minus 1 I equal to hash, then continue, that means I want it to be 0 only. Now these are the bounds, that low is equal to max of I minus d. So basically I minus d to I plus d I am doing, but it has to be inside the bounds also, so I am taking the max with 0 and also min with m minus 1. So this is the bound on k, like dp of n minus 1, the last row. If you want to be on I, then you can come from anywhere from low to high. So the sum, like to calculate that, you will use a prefix sum to pref of n minus 1 comma high plus 1 comma 0 minus pre of n minus 1 low comma 0. And also you cannot come from the same cell, like to n minus 1 comma I, you cannot come from n minus 1 comma I, so you subtract the dp for that also. subtract dp of n minus 1 comma I comma 0. Right, that is one caveat here that I also caught using during when I was coding, right? So this is how you calculate the dp1 for the last row, and then you just take the prefix of that row, right? Now this is sq. I have defined a constant, like this is the parameter by which we can transition. Okay, now from the second last row up to the last row I'm iterating. First of all, I am doing that dp of ij0. Okay, the type 0 I am calculating using prefix of I plus 1 comma 0 minus, yeah, so the I plus 1th row of 0 type or of 1 type, both we can use. So this is what it means. And then I just take the prefix sum, and to calculate the type 1 for the ith row, I can transition from I comma 0, right? But subtract I comma j comma 0. So this is basically the same as what we did here while calculating the dp1 for the last row. Okay, so we did that, and again just take the prefix for the dp1 as well, right? So we iterate through all the rows using this for loop, and at the end my answer is just the sum of all the dps in the 0th row, and that is also prefix sum of m, like the last prefix sum, that is the sum of all dps. So I just printed that pre of 0m0 plus pre of 0m1. Okay, I hope it is clear to all. Okay, if it is clear, then all right. If it is clear, then I will take your leave, and thank you all for joining in, and bye bye. I'll see you guys next time.